You get 9/2. Hopefully. Someone back me up?
Yes.
Cool.
Yeah.
Plus 2. Okay, good, next problem. Next problem says, find the area enclosed between some parabola and cosine. Yikes, that sounds really hard. It is. Not really. Y equals 2 cosine x, and y equals x squared minus 1. So, x squared minus 1. We know how to graph that. It's like a parabola. But 2 cosine is going to look kind of like that or something. Alright, I'm cheating by just like doing the problem for you because we're running out of time, but I'm sure you could do this. This is the green region, you need to find the area. Man, Ethan, that sounds hard. Why is it so hard? Yeah, because I just like can't, in order to integrate this, I mean, I know how to anti-differentiate both these functions. That's no problem. The problem is in finding this point of intersection. I mean, I could just put you in a room and say, yo, solve 2 cosine equals x squared minus 1, and you guys will either give up or like be able to just like go crazy or whatever, but you will not be able to do it. And so we are forced to use a calculator for this problem. So let's just work on our calculator skills. So you got your calculator? Which one you got a calculator? Guys, need to bring your calculator every day for the rest of the year. So here's what you do. Go into y1, type 2 cosine, make sure you're in radians. Go into y2 and type x squared minus 1. And then graph them. And graph them on a nice happy interval. Like say from, I don't know, -2 to 2 and -3 to 3, something like that. Yeah, I know, because it's hard. You can do it, man. You gotta like find some knob that like makes it go like up and stuff. Alright, so when I graph them, I get this. Is that what you get?
Oh wait, you zoomed in.
I zoomed in a little bit, yeah, I set a window, but you don't really have to, it just makes it pretty. Okay, so goal is to find the point of intersection between the two curves, right? How do you do that? Do you guys know how? How? You go second, trace, and then just like we did, I think it was just last class we did this, right? With the 0 feature,
Intersect.
now we're using the intersect feature. So if you go intersect, now what the calculator is doing is is going to find the exact point of intersection of any two curves. You might have like 8 curves up on the screen, so the first thing it's going to ask you is, which 2 curves are you intersecting, basically. So it says first curve, it puts the cursor randomly on one of the curves, it says first curve, yeah, calculator, yes. Second curve, the other one, yes. And now it wants to know, it wants a guess. The guess is just like the input to some Newton's method-like algorithm, which is going to rapidly converge numerically on this number as being the place where the curves intersect. Since we're doing this problem by calculator, we can't do any intermediate rounding. So you don't just write down like 1.26 and then call it a day. You have to use that exact number up to the number of digits that your calculator stores. So you have to store that value. When you perform this intersection operation, your calculator dumps that value under x. So then you get x, and now that number is the place where they intersect. So x is very volatile. Like anytime you move the cursor or do anything, it replaces x with something new. So you need to store it somewhere safe. So you're going to store it as, like, for example, a. Did we do this last class? We did, right? Or we tried to, but like the bell was ringing, right? Kind of. Ish.
No. We were doing this at gravel and...
Yeah, we're doing the gravel problem, right?
We didn't do that.
But we didn't actually finish it.
When did we finish it?
Okay, good. So we get 1.26, blah, blah, blah. And now what do I need to do? I need to take the integral. Oh, by the way, since both of these functions are what's it called? Even, actually the smart thing to do would be to just say, what I really want is just the integral, twice the integral from 0 to a of 2 cosine x minus x squared minus 1. And as like parentheses are annoying, the simplest thing to do is to use y1 and y2. So look back at your y1. Personally, I put cosine in the y1 spot, which is the top guy, and I put x squared minus 1 in the second spot. Thus, the integral should be math 9. Oh, actually, I want to go twice.
Wait, how do we do that again?
Twice the integral from 0 to a of y2 minus y1. So you just go bars, y bars, function y2, minus bars, y bars, function y1. That is the function I would like to. So that's the integrand, and dx. Boom. Except I did something wrong. Oh, this is y1 minus y2, it should be. For me.
No, dx.
So did you guys get 4.994? 4.995 rather? Okay, good. Last problem. The most important one. Read it and make a picture. So we want between y equals x and y equals x squared over 4, but only in the first quadrant and below the line y equals 1. Yikes. So where does x and x squared over 4 intersect? It's whenever 4x is x squared. So I guess it's going to happen at x and 4, right? You with me? Let's assume that you are. And when you plug in 4, you get like 4, something way up here. So I think what I have is the line is, the one line, the line y equals x looks like this. Then the parabola looks kind of like, when I get to 4, it's like 4.
Oh, we need to, okay.
But only underneath the line y equals 1. And when does x squared over 4 equal 1? When x is 2, right? Okay, so contrary to my picture, which looks a little bit crappy, this is the region that I want to find the area of. Like 30 more seconds here. This is the region. It's the region in the first quadrant bounded by the line, the parabola, and the line y equals 1. All right, what makes this region different than all the other regions that we've looked at and thus kind of more annoying?
There's the y.
equals 1.
There's the y equals 1 thing, so what's the problem kind of?
It's like 3 kind of functions.
It's like 3 kind of functions. Yeah, now a single representative rectangle will no longer suffice, right? Because on the interval from 0 to 1, the rectangle will be line on the top, parabola on the bottom. But on the interval from 1 to 2, the rectangle will be like horizontal line on the top, parabola on the bottom. So that's one way you could do it, is you could split it up into 2 separate integrals. But the real way to do this problem, which we're running out of time for, but you're just going to figure out on your own, is to go sideways.
Why?
Because if you go sideways, then the guy on the left is the line, and the guy on the right is the parabola. So what you're going to do is you're going to express x in terms of y and integrate with respect to y up the y-axis. Or there's a cool way to do it, Mateo. Take out that triangle, right? Yeah, that's another cool way for that problem. All right, good. You'll figure it out. It's in the book. I'll see you on Tuesday.